Hello. All right, so we're going to start with notes that we took today in class on Module 4, Lesson 3, Multiplying Polynomials. Today's November 7th, 2025. So if today's the day you missed, we're going to start by reviewing the FOIL method that you probably learned in Algebra 1. So an example of that would be if we had the quantity of x plus 4 times quantity of x plus 3, right? And then FOIL says that we would multiply our firsts and get x times x, which is x squared. Those are our firsts. Then we would multiply our outer, so this outermost to that outermost. X times 3 is going to be plus 3x. Those are our outers. Then we're going to do our inner terms, which would be 4 times x, so plus 4x. That's the inner term. And then our last terms, the last term of this polynomial, last term of this binomial, right? 4 times 3 is 12. And those were our last terms. And then I often say oi, meaning that the O and the I are often like terms, so we can combine them. And sure enough, that's the case here. So we get x squared plus 3x plus 4x would be plus 7x plus 12. And that's perfect. And there you're done. Okay. And so that is how we use the FOIL method to multiply polynomials. But when we get into Algebra 2, often our polynomials are bigger than just binomials. We'll get into trinomials, etc. And so this gets a little complicated because it's not as neat as just the F, the O, the I, and the L. So if we were given, I'm going to use box method to show this next strategy. If we were given the product of polynomials such that x plus 3 times the quantity x squared minus 2x minus 6, we can see that FOIL wouldn't work because it would be firsts, outers, inner, and last, and we would never multiply that negative 2x, which we for sure need to multiply that negative 2x. Darn it. So another option is instead of, it's still FOIL method, you just don't call it that, but you take the first term of the polynomial and you multiply it by that, then the second term, then the third term of that. Same thing with the second term of the first polynomial. You would multiply it times the first term, then the second term, then the third term. You just have to make sure that you're multiplying everything in the first polynomial times everything in the second polynomial. Well, that's what I really enjoy about the box method, is that it's organized so you can make sure that you multiply each term by each term in the other polynomial. So when I set up my box, I'm going to just do x plus 3 . And then I'll write the second polynomial on the top, x squared minus 2x minus 6. I do try to give myself a little space so that I have room to write what I've multiplied to get. And I put a little multiplication dot in the corner to remind myself that I'm multiplying. Now, if you're already mad because you wanted to write the second polynomial down the side and do just the binomial on the top, that's totally fine. You will get the same exact answer. It doesn't matter one bit. All right, so then we just start multiplying across the table, across the boxes. So x times x squared is going to give us x cubed. If you're not sure why, then let me remind you that this x has an invisible exponent of 1. And then if we were here the day that we made our laws of exponents poster, then we would be looking at this product of powers rule that's talking about when we have the same base. So multiplying with the same base, we're going to add the exponents. So multiplying same base, we add exponents. Well, that's what we have here. We have the same base, x and x. So we're going to add those exponents. 2 plus 1 is 3. That's where we got the x cubed. Then we have x times negative 2x. Well, you can pretend that there's an invisible 1 out here if that's helpful. 1 times -2 is -2. X times x is x squared. So you get -2x squared. Then we've got x times -6, -6x. Then we come to the bottom row. X squared times 3, we get 3x squared. Because again, there's just an invisible 1 here. 1 times 3 is 3. X squared times, there's nothing there, would be x squared. -2 times x times 3 is going to be -6x. And then we have 3 times -6 is -18. Then very frequently you end up with like terms being diagonal from each other. So those are like terms, they're both x squareds. And then these are also like terms, they both have an x. So I'm going to write out the whole next step, although often we do this next step in our heads. So we're going to combine like terms. I get x cubed plus 3x squared minus 2x squared. Notice I pointed out that these were like terms, so that then I could write them next to each other in my problem. And then I'll do the same to the next like terms, minus 6x minus 6x minus 18. From there, I could also make this bigger, I'm so sorry. From there, we need to combine our like terms. So the x cubed has no like terms. He's all by himself. But then 3x squared minus 2x squared equals a positive 1x squared. You can write the 1 or not put the coefficient 1, doesn't matter. Then we've got -6x, -6x. Those are like terms. We have same signs. They're both negative. So we'll add that together and get 12. And we'll keep the negative sign. So -12x, don't lose your x. And then the -18 has nobody to combine with, no like terms. And so there you go. So then from there, we're going to go on to, I've heard it called double distributing. But then our book calls it horizontal method. Doesn't matter what you call it. I'll show you how to do it. Oh my gosh, we have extra space. What should we write there? Math is so fun. Yay. All right. I'm sure that our notes would not be complete without that. Okay. I'm going to take the same problem that we used in our box method so that you can see it doesn't matter which strategy you choose. So we've got the quantity x plus 3 times quantity x squared minus 2x minus 6. And then let's keep track of what steps we're doing. So over here on the side, let's write. We're going to write the second polynomial twice. This is not actually precise language because we're actually going to write the second polynomial for as many terms are in the first polynomial. We have 2 terms in the first polynomial, so we are going to write the second polynomial 2 times. So I've got x squared minus 2x minus 6, and then I need to leave a little space, and then x squared minus 2x minus 6. So if you see that, I just wrote this second polynomial twice, exactly as it is. Then our second step is we're going to distribute the first polynomial. So this is my first polynomial. I'm going to distribute the x just outside the second polynomial so I can multiply it by everything inside. And then I'm going to move the plus 3 and distribute it here so that I can multiply that 3 times everything inside the second polynomial. And then from here, you guys are really good at this part. So we're just going to distribute the x and multiply as we go. Some people draw all the arrows or the rainbows first. I like to draw one arc or rainbow, whatever you'd like to call it, do the multiplication. So I'm going to go x times x squared gives me x cubed. Then I write the next arrow or rainbow. X times negative 2x is negative 2x squared. Then I do it one more time. X times negative 6, we get negative 6x. And now I am done with that, like with that half of our multiplication problem, right? And now I'm going to do the second part. So now we've got plus 3 times x squared, so plus 3x squared. You may notice that I draw my arrow from the plus sign, because if that's ever a negative sign, if it had been a minus 3, it's really important that I am multiplying by a negative 3 to everything inside. But this one's positive, so plus 3 times negative 2x gives me negative 6x. And then we've got plus 3 times negative 6 gives us negative 18. Then let's add a third dot for our third step. We need to combine like terms. So x to the third, I do not have any other to the thirds, right? No more x to the third. So he's just going to come down all by himself. But here I have negative 2x squared and plus 3x squared. Those will combine. So what is negative 2x squared plus 3x squared? They're different signs, so I'm going to subtract. 3 minus 2 is 1. So I'm going to have the positive x squared. Next, I'm looking at the minus 6x, minus 6x. Those are like terms. To combine them, they're both the same sign, so I'm going to add 6x plus 6x is 12x, and I'm going to keep that negative sign. Then lastly, I have a negative 18, but nothing to combine it with. And that's where it ends. Check it out. It doesn't matter how you do it. You get the same answer. Okay, here we are again. So we are on page 61 of the HMH workbook for Algebra 2. It is Module 4, Lesson 3. So we are multiplying polynomials just like we were in our notes. And so they are going to teach us the vertical method and then the horizontal method, and then I'll show you the box method. So I do not enjoy the vertical method, but let me show it to you in case there's anybody out there who loves it. But to understand it, you have to remember how to do multiplication, double-digit multiplication like this. So you have to remember that you've got to know your times table. So 6 times 8 is 48. 6 times 6 is 36, plus 4 is 40. Then often teachers teach you to put a 0 for a placeholder because now we're using the tens column. So then 4 times 8 is 32. 4 times 6 is 24, plus 3 is 27. And then we add all of those together and we get 3,128. And so then this vertical method is just doing all of those steps with polynomials, right? So we would start with the negative 4. We're going to multiply it times plus 3c, and that's where we get negative 4c. Then you're going to stay with the negative 4 and multiply it times the c squared, and that's where they got negative 4c squared. Then once you're done with that term, you're going to go to the c, right? And we're going to do c times the plus 3c, but you need a placeholder here, or at least move over, because you want your c squareds to line up. So we've got c times 3c is plus 3c squared, and then we've got c times c squared is c cubed. Beautiful, beautiful. Then one thing I do like about this method is that then our like terms should be lined up so that we can combine them. And so we have negative 4c squared plus 3c squared gives us negative c squared. And then we still have our c cubed, and we still have our negative 12c. All right. Well, let's go ahead and look at it in the horizontal method, right? This is the one that in our notes, I think I called it double distributing. And we have those steps written down. So they started by taking the second polynomial and writing it twice, just like we did. Then they took the first polynomial and they distributed it. They put the c in front of the first version of the polynomial, second polynomial, and then they put the negative 4, don't forget the negative, next to this polynomial that they wrote the second time. From here, you guys are great at this part. We just distribute. C times c squared is c cubed, sorry. C times 3c is 3c squared. Here, I'm going to take my time a little more because we want to make sure that we're seeing this is a negative 4 times c squared. So we get negative 4c squared. And then this is a negative plus 3 squared, which is negative 4 times 3 is negative 12c. Then we've got some like terms here in the middle. So the c cubed comes down, but plus 3c squared minus 4c squared is going to be negative 1c squared. And we still have the minus 12c. Now let's put it in box method. So again, the thing I like about the box method is it just helps me stay organized so that I don't lose any terms or I don't forget to multiply by any terms. So we've got c minus 4 on the side and c squared plus 3c along the top. Trying to give myself a little space inside the boxes so that I can write my answers. However, if you wrote c squared plus 3c down the side and wrote your c minus 4 across the top, it'll work out the same. It'll be perfect. All right. So imagining that we have an invisible 1 there, c times c squared is going to equal c cubed because we've got the same base. So we add our exponents when we're multiplying. And then we'll do it again here. 3c times c. You can imagine there's an invisible 1 there. So 3 times 1 is 3. C times c is c squared. Negative 4 times c squared. Again, we can imagine an invisible 1. Negative 4 times 1 is negative 4. C squared. And then negative 4 times 3 is negative 12. And we still have a c. Always check to see if we have any like terms. I see I've got c squareds as like terms. And so then I'm going to write all 4 of those down so that I can combine my like terms. So I've got c cubed minus 4c squared plus 3c squared minus 12c. And then I'm going to combine those until I get to my final answer, which is 3c minus c squared, because negative 4 plus 3 gets me closer to 0, but not quite. I'm at negative 1c squared minus 12c. And then check it out. Doesn't matter how you do it. They all end up the same. So whichever way works for your brain is the way you should do it. Let me give you a hint before you start off on the problem on your own. On the do your math, you've got the given product. They just want you to write the problem again. So like this problem that's right here, write it again. All right, go ahead and pause here and try to do it without me. All right, I'm back. So I'm just going to copy the problem, 3w minus 5 times 2w squared minus 4w plus 7. I'm not going to worry about staying inside boxes that are too small. I just try to make sure I write dark enough so that we can see it, okay? So they have literally taken our second polynomial and written it twice, right? In our notes, that's what we tell us the first step is. So they have taken the first polynomial, they've written it twice. So then our job is to take the first polynomial and distribute it. Now, some of my students were getting messed up with this plus because they're like, it's a -5. The book is assuming that they don't know if it's plus or minus. So they're always going to write plus, and then if we know it's actually minus, we're just going to put our minus or a negative sign inside our little box. Okay? Right? And then we have to multiply, right? So now we're just going along. 3w times 2w squared. 3 times 2 is 6. W to the third, because 2 plus 1 is 3. Then we have to do it again. 3w times minus 4w. They did give us the minus here. Is going to give us negative 12w squared, because we've got 2 of them, right? Then we've got, plus 7. I still have to multiply one more time, right? 3w times 7 is going to be 21w. You could write to the first power if you wanted to, but I would not. We don't normally write it. No. Now I'm on to the 5s, right? So let's do this. -5 times 2w squared. -5 times 2 is going to be negative 10w squared. Then -5 times negative 4w. -5 times negative 4 is going to be, a positive 20. And then just w. And then -5 times 7 is negative 35. Then we have to look to see if we can combine like terms. So I don't have anything else cubed, so I'm going to go 6w cubed. But then I have this negative 12w squared and a positive 10w squared. Oh, actually a negative 10w squared. So they're both negatives, they're both squareds. I'm going to add them, but keep my negative sign, and that'll give me 22w squared. Then our last part is going to be this 21w to the first power and a 20w to the first power. So 21 plus 20, we get plus 41w. And then he's all by himself, the negative 35. And that's where we are. Nice job, everybody.